Thank you for your time today. Today we're going to discuss a new technology for online commerce associated with semiconductor manufacturing. But before we start, it'll be helpful to examine how we got to this point and the significance of where it may lead us. It's important to realize that the internet hasn't really been around all that long. It all started in 1969, and 40 or so years later, this technology has significantly impacted pretty much everyone. I think it'll be useful to track the average cost of an internet transaction, which is what these red circles here do. I've written quite a bit about the collection of markets we call Internet of Things. I believe these markets will reinvigorate the semiconductor industry with new design starts. Will simplified access to semiconductor technology enhance that number of design starts? Absolutely, and this will be an interesting thing to watch moving forward. This slide depicts the order of magnitude of three portions of IoT. There will clearly be a lot more impact to our lives given the size of these numbers. While blogging and social media are important aspects of the internet and form a life-changing communication backbone, people are also transacting a lot of business on the internet. Here are more examples with a steadily increasing transaction value. People are buying cars, financing houses. Pretty much you can buy everything through the internet today. Amazon is an important provider of internet commerce for many of us. I use Amazon a lot. My book is on Amazon. I buy all sorts of things. My wife and children use it even more. This photo really drives home the size and scale of Amazon. Believe me, there's a lot of physical infrastructure behind that website that makes it all happen. So the question that I would like to discuss is, how did all this e-commerce actually happen? Simply put, the semiconductor industry, and more specifically the integrated circuit, made the networks, computers, and point-of-sales devices that power e-commerce possible. What about the semiconductor industry itself? For the most part, this industry really hasn't taken advantage of e-commerce. E-commerce allows the customer to independently browse choices, try out ideas, see what the results are, and fully explore options at their own pace wherever they are. Until recently, design teams that build ICs didn't have this kind of opportunity. Last year, eSilicon launched a first-of-its-kind online portal for multi-project wafers, or prototype quoting. Recently, the capability has been expanded to include full-scale production in collaboration with TSMC. For one thing, these portals are really driving up the value of an internet transaction, as you can see here. eSilicon's claimed improvement in the time to conduct business is also noteworthy. Here are some of their statistics for multi-project wafer portal. There's clearly a global effect here. Now let's see a live demonstration of eSilicon's new online portal for producing quoting. They claim 7 steps to complete a quote that eSilicon will then stand behind. In the past, eSilicon has made some pioneering contributions to the ASIC business. Let's see if this is another one of those pioneering contributions. You can read more about eSilicon's history in the ASIC chapter of the book Paul McClellan and I recently published. It's called Fabless: The Transformation of the Semiconductor Industry, which, by the way, is also available on Amazon in print version, or you can get an electronic version on SemiWiki. I'll now hand it over to Jeff Porter. Jeff is the architect of eSilicon's online business technology. He will drive the demo. And Bob Dunnigan, VP of Operations at Iconos, will also participate. He will specify the choices for the quoting process. Jeff?
Thank you, Dan, for that introduction. And good morning, everyone. Morning, Bob. How are you this morning?
Very good, Jeff. Thanks for having me today.
Let me go ahead and share my screen.
Yeah, so while Jeff is setting up, we're transitioning presentation here. While he's doing that, just another quick comment I'm going to make is Bob is going to be driving this demo live. So we don't know what his inputs are going to be until he tells them to us right here live on the screen. Just to prove that this is a live demo, I'm going to interrupt this demo at a couple of times, and I'm going to ask you the audience to provide an answer to a couple of the menu picks here as we go through this series of menus to generate a real production quote through TSMC for tape out and production volume. So heads up there, I'll be asking, and you can provide the answer in that chat window as I mentioned. So I think we're ready to go. I'll turn it over to Jeff and to Bob.
Thank you, Mike. And Bob, thanks again. Why don't we dive right in here and get started on our demonstration. As Dan mentioned, we have 7 steps to create the GDS2 quote. Step number 1 is the project name. What would you like to call this project?
Let's call this project Excelsior.
Excelsior. Great. I like that name. Little Latin. Okay. Process technology information. GDS2 Online currently supports TSMC as the foundry, and we have process technologies ranging from 350 nanometer to 28 nanometer currently supported in the UI. Which process technology are you interested in today, Bob?
Well, let's go with 40 nanometer technology.
Okay. And something that's good about our user interface is that it guides the user to the options that are available based on previous decisions. So as we just saw, when Bob selected 40 nanometers, the flavors that were available became GLP and MSRF. If just by example I go back and select 28 nanometers, we'll see that the flavors available are those that belong to 28 nanometers. And we'll see that trend throughout the UI, that it guides the users to the things that are available. How about the flavor, Bob?
We'll do a high-performance product today, so let's do the G-based technology node.
Okay, great. That's selected. And on a number of metals, we support the 40 nanometer metal stack, similar to what I showed for the flavors. These are the metals that are available in 40. If we had selected a different process technology, a different subset of metal layers, number of metal layers would be available. How many metal layers in your project?
Let's go with 7 at this stage.
Okay, 7. Got it. Perfect.
So I'm going to interrupt you guys here once on the choices. So Jeff, if you could pull down the list of metallization options, I'm going to ask the audience, what would you folks like to pick for the metal options here? So I'll wait till we get the first response back, and I'll let you know what that is.
Okay. We're waiting for that first responder.
Yeah.
I'll just quickly show that we had selected something maybe like 180 nanometers and a G process there. We see the number of metal layers is dynamically adjusted to be lower. So it's not, the tool is not allowing you as the user to enter something that doesn't exist, and it's guiding you to the choices that are available. I'll just quickly flip back to 40 nanometers. You can see we can flip back and forth between the different technologies and options quite easily.
Okay, so you want to go back to 7 there, and then I got quite a few responses. The first responder was the third one on the list there, so 7M for X.
1Y, 1Z. All right.
That's it. Okay. Thank you.
People have spoken. Got it. Okay, now we're on to the process options. So here we have all the options that are available in this foundry and technology. If some of them aren't available, they're grayed out so that you don't get a chance to select them, but you're also aware that they do they exist, but they're just not available for this particular combination of technology and then flavor. For your project, Bob, which options would you like to go with?
Well, since we're doing a high-performance project today, let's do a flip chip bump. So let's choose the LF bump technology.
All right.
And we'll manage our power by using the high voltage threshold.
Okay.
And we will still need low voltage to get the critical speed pass done. So let's select that as well. And then for our cores, we'll need optional VTs for the N and P device. Yes, so those two would be perfect.
Great. Okay. Now we see here we have a nice summary of what's been selected. The first choice that Bob made was on bump. We'll come back to that when we're selecting package. So just keep that in mind, is that Bob selected a bumped die at this point. Okay, now we're on to the die information itself. This is things like the die size and amount of repairable memory and so on. Bob, what are you thinking here?
Okay, let's do 8.3 by 9.7 millimeters.
Gotcha. We'll see the UI automatic updates provides us the scribe line and the gross die per wafer for that die size that you selected. Some useful information. So it's not just a one-way. Data is being provided back to the user as well. Next, we have a non-repairable SRAM analog die area.
Okay, so our chips typically have quite a bit of memory, and some of it is non-repairable for sure. So let's do 20 millimeters.
20 millimeters. Okay, got it. And analog die area.
And maybe 1 millimeter.
Okay. Probably just a PLL, it sounds like.
Yeah, some basic circuitry.
Okay, and on the, this you said was a bumped die, so we have here a bump pitch of 150. We can go higher up to 240 perhaps, but what are you thinking for bump pitch and bump count?
So we're going to put a lot of bumps on here, power and grounds and various signals. So let's stay with 150.
Okay.
And let's go with a bump count of 3,000 bumps.
Okay, got it. All right, we've completed section 3, and now we're into the package section. So we'll go ahead and click on flip chip. As Bob selected lead-free bump, only flip chip packages are available. And just before we continue with Bob's specification, I'm just going to head back up to the process technology. Let's unselect lead-free bump just for a moment and come back down, and we'll see now we have a complete selection of wire bond packages available. There's over 1,000 different combinations of packages that are supported by the tool, and they can be customized, as we'll see, down to the layer, down to the number of bond wires, down to the number of balls. So quite a lot of options available and customization available on the packaging side. But I'll go back and select that lead-free bump, and we'll go ahead and take a look at the flip chip BGA packages. And Bob, did you need a flip chip BGA here, or did you also want to have a heat spreader with the lid on there?
Just the flip chip at this point.
Gotcha. Okay.
Try and conserve cost.
Okay. Makes sense. And then we have body size and layer count are next.
Okay, so the die is fairly large and the pin count's fairly high, so we're going to go with the 17 by 17 BGA.
Okay, and we can see here we support body sizes ranging all the way to 52.5. We'll select 17 for 17. And then we have the layer count here. So this is supporting 121 down to 343 build up for this body size. We also support up to 646 for the larger package body sizes. What layer count would you have in mind here?
Let's do 222.
222. Gotcha. Okay. Okay. Next is the ball pitch.
And we're going to interrupt you guys again, and we'll take requests from the audience for this one.
Okay.
Who wants 0.8 versus 1? Again, we'll wait for the first response, and we'll go from there.
Okay.
Okay, we got 1 as the choice. Thank you very much. Actually, I got several responses. Everybody said the same thing, so that must be the right choice.
The wisdom of crowds.
There you go.
Everybody's concerned with the escape routing at 0.8. So
I don't recommend you design a chip by committee like this, generally speaking. I don't think it's a good idea. It's fun to do.
Okay, and the default assembly yield for this package is 99.8%. Any change there, or would you like to go with that default?
That's fairly standard, so let's stay with that.
Okay, it is modifiable, just so folks know. Delivery, we can offer you either for this body size, package delivered in a tray along with the desiccant, or we could also go with a package in tape and reel.
Tray.
Great. Okay, now we're getting more than halfway through. We're in the wafer sort here. So first we're going to select the tester. Here's just a list of the testers we have available, ranging from a J750 to 93Ks down to a Teradyne iFlex, different number of ball counts and memory configurations. What tester did you have in mind for today's project?
Very nice selection here. We're using Verigy 93Ks and typically a C400E configuration with 384 pins.
Okay, selected. And how much time were you thinking for wafer sort?
About 7.5 seconds per die.
Okay, go ahead and select that. Index time is defaulting to half a second. Is that okay, or would you like to change that?
That's pretty standard with the probers we're using today.
Okay, great. And number of sites, is a single site or multi-site?
Yeah, let's start with single site and see how we do.
Okay, great. And our yield, based on the information that we've collected in the UI so far, is predicting a wafer sort yield of just under 83%. How does that sound?
That looks a little bit low. Let's boost that up to 90% if we could.
Sure. We'll go ahead and just boost that to 90%. Got it. Okay. So we're done with wafer sort. I'll go ahead and minimize that. And now we're on the final test. And same selection of testers available. Would you like to use the C400E again or something else?
Yeah, we try to keep with the common platform.
Yeah, makes sense. Okay, and then here we have test time per device, index time again.
Okay, so we're doing a little more testing here with speed, so we're going to go up to 8 seconds.
Okay, great. And what about the number of sites? This is, I'm assuming, single site again?
Still a single site, yeah.
Okay. And our model is predicting, based once again on the inputs we've received so far, about a 97% yield at final test. How does that sound?
Yeah, that sounds perfect with the expectation that we've weeded out product at sort, so very good.
Okay, cool. All right, we're on to the final step, which is the tape out and production forecast. What's your targeted tape out date for this project?
So end of the year, December 1st. Let's do the before Christmas time.
Okay, happy holidays. And then last step, it's hard to believe we're already on the last step. What's the forecast here for per year?
So it'll take us, 9 to 12 months to get to production. So 2015, let's start out with a 250K volume. And then
Okay.
we'll ramp basically to that run rate, 1 million a year. So 1,000 for 2016, 17, and 18. And then as we get into the end of life, it'll start to fall off. So maybe 500,000 in 2019 and 250 in 2020.
Okay, so I think I got 250, 1 million, 1 million, 1 million, 500K, and 250K.
Yeah, that looks good.
Okay, great. So we're done. I'm going to go ahead and hit the quote button. And Bob, you've received and sent out a lot of RFQs for ASICs and received a lot of quotes over time. How much time do you typically take for a supplier to get back to you with a quote?
Well, it varies obviously with the technology nodes, but anywhere from a week to 2 weeks to get a detailed quote back.
Okay. So how much time does best? About 5 seconds?
Yes, I think so.
Yeah, so this is the quote. This is what was generated from those inputs. I'm just going to scan through it here, highlighting some of the sections. As we put together this tool, we really want it to be a no compromise experience. And to us, that meant 3 things. The first thing was that you would get it fast, that you shouldn't have to wait 2 weeks or longer to get the number. And the second thing was we wanted it to be complete. As we can see, this is a complete document. It's about 24 pages in length, and it has all the information that you would need. And then the third part of that no compromise experience was that we wanted it to be something you could count on. So you can get a lot of people tell you this is the number I think, but it's budgetary, which basically means don't count on it. Here you can count on it. This is an executable contract, and as you can see in the section 2, we have the NRE pricing. The first row is for the development and design of the package and the tooling for that package as well. In row number 2, we have the manufacturing kit That includes the mask set, the test hardware, load boards, probe cards, things like that, prototype wafers, and assembly of some prototypes for you. So pretty complete there. Then we also quote as a included service a ESD qualification on the device. So that's everything you need in order to get started, along with a test program development as well, targeted to the 93K C400E, I believe it was, you selected. So
Yes, correct.
That's complete there. Here's a list of billing milestones of when these payments would be due. Oops, sorry about that. Got away from me there. And then we move on. We have some optional services which are included. And these include things like a package electrical simulation. So about if you had any DDR interfaces on there that you want to do some bounce analysis on, or some SerDes that you wanted to look at over the electrical range, we can support that. And we also have some other services as well. What we're determining, these are optional, but if you'd like, we can do a PVT analysis, see how it yields over the different process corners at different temperatures. And we can also look at doing some other qualification efforts around the package for burn-in, if that's something that would be interested in. Those are all priced out for you here as well.
Okay.
Billing milestones follow after that for the optional services. Then we have our additional prototypes. If you'd like to buy any, those are available from that those initial 6 wafers that we've started up in the NRE section. Before you've production released your product, if you're looking to buy some parts but the yields aren't yet fully understood, we do offer lot buy pricing, and that's here in section 2.3. If you did need a respin, we offer the quote here for the respin, so it's already embedded there. You're not going to have to worry about it later on, or go back to your salesperson and ask them to quote it. And when you're feeling the pressure, it's a buy an all-layer respin, and then buy each individual metal layer as well, if that turns out to be what you needed.
So we
okay,
can,
now we're.
so we can pick and choose between the metal layers if we have an ECO that we need to implement.
That's right. That's right, and that pricing is fully detailed from the start. Okay, now getting down to the production pricing. This is the forecast that we entered into the UI, and then here we see in 2.6 the production yield assumptions. So we have things like the 90% and the 99.8% yields, the gross die per wafer estimation based on the die size that we entered. And then we have here 2.7 is the production pricing. And so we can see for a minimum order quantity of about just under 17,000 units, we'll start out at about $15.20, and then over time go down to just under 14, or over volume, I should say, go down to just under $14. We also provide plus and minus 5% at the wafer sort yield. So you can see here what the sensitivity of the unit price with yield is. What do you think, Bob? What do you think about this quote so far?
It's a little higher than our initial target, so we were looking more at $14 as our starting point. Is there any way to get us into that range?
Yeah, well, let's see what we can do. Let me just quickly show the rest of the quote here, which contains some boilerplate, quite frankly, and then we get into here's the signature block. So it is an executable contract. And then in the appendices, we're seeing a description of what's been offered and what was put in, so you can see clearly what was selected and so on. And we see here, if I look at this technical solution, without changing things like the process technology or the die size, maybe, things that are, or number of layers, things that are maybe fundamental to the design, do you have any, would you consider a dual site test? Is that something that is possible?
Yeah, I think working together on DFT, we could maybe reduce the number of pins required and do dual DET.
Okay. And is it possible maybe on the package to go down a level and have a 121 instead of a 222?
Yeah, 121 is a cheaper platform for sure, and maybe we don't need the extra power planes in there.
Okay. Why don't we go back then to our UI and try that out and see what we get. So I'll just say call it Excelsior. I'll just call this Excelsior cost reduced. And I remember I might have to ask you to remind me of some of the inputs here, but I know we were in 40, I know we were in G, I know we were in 7.
7 layers.
And I remember Mike said it was the third one down.
Correct.
Correct.
Okay. I remember it was, what were the other options you had, Bob?
We used the high and low VT as well as the 2 core implants.
Okay, great. Thank you. All right. Could you remind me of what your die size was?
8.3 by 9.7.
Okay, great. Thank you. And I got the. Remember you said 20 for the.
Yeah, 20.
One.
And 1 on the analog.
And 3,000 for the bump. Okay, great.
Correct.
That's all for that section. All right. Now we're back to the package. And 17 by 17.
17 by 17.
Okay, and we're going to try the 121, and all the audience selected 1 millimeter for the ball
That was
pitch.
a popular answer, yep.
We'll go with those. It was package and tray. We can see we're actually getting our second quote a little faster than the first. After folks get used to the UI, that'll happen. How many tests? What was the test time again?
7.5.
Okay. And then this one we're going to try for dual site. So I'll go ahead and select dual site. And we'll see that we have a multi-site efficiency factor by default of 80%. It's accounting for the overhead. We could make it 100%. That's probably a little unrealistic, but that's going to, at 80%, it makes our effective test time per device at around 4.7 seconds. So there is some improvement there. Does that sound okay?
We did have the yield at 90% previously.
Yeah, let's go ahead and change that. Good. Okay, great. We'll just go ahead and move on to final test. And here, did you say 8 seconds? 8 seconds.
8 seconds, correct.
Great. I remember it was December 1st.
Correct.
And then it was
250.
250, 1,000 for 3 years?
$1 million, 500,000, and 250.
Okay. Let's generate our second quote. See if we can do some analysis on what the trade-offs would be for package layers and the test going to dual site. And I don't know what how much time it typically takes to get that type of information after you've gotten the first quote, but this was very quick. I'm just going to quickly go ahead and stream down to the unit pricing here. And we can see we're now in the 1485 range. So that was some improvement there. Down from
15, 20, so about 40-cent change. Nice.
Yeah, and then obviously you can keep going back to the tool and going back to your engineering team and your marketing requirements and trade those off as the project develops and as things happen. Get some instant feedback on what it means to what a technical change means to the commercials. That concludes our demo. Bob, did you have any final thoughts you wanted to share with us before we throw it back to Mike?
No, very nice, very flexible tool, allowing us to do various different scenarios fairly quickly to compare the various different technology and testing options that we might have available to us. So, very nice tool. You're going to put the lawyers out of business though with that automated quote.
I don't think there's going to be many people objecting to that. Really appreciate your help today, Bob. Thanks so much.
Yeah.
Not a problem. Thanks, Jeff, for having me.
Back to you,
Thanks
Mike.
a lot. By the way, any lawyers on the line, he didn't mean that. We love you and we need you. Business doesn't run without you. So yeah, leave the quote up there, Jeff, because we do have a number of questions from the audience. So this is good. We can kind of go through this. So the first question: are the choices limited by what is supported in the originally selected technology and node? So I'll take the easy one. You can take the hard ones that come later. But yes, the answer is yes. What Jeff had mentioned is that the choices you make earlier basically limit the subsequent choices to be the ones that make sense only for that technology choice. In fact, that was one of the major design goals of this interface. If you think about it, the number of options to tape out a chip in a TSMC process node is rather staggering. There's lots and lots of data. And the way we managed the information explosion and made the user interface more manageable is by doing exactly that. So as you go through the menus top to bottom, you're limiting your choices in the earlier stages so that the things you see later are only the things that matter or make sense for what you've requested earlier. So that's actually good for two reasons. Number one, it reduces clutter and reduces the complexity. The other important point is, with this interface, you can't request something that's invalid. Anybody who's done a quote manually for custom IC knows that one of the things people live in fear of is, do I have the right options? Have I picked a set of options that don't necessarily play together well at the foundry? It's kind of rough finding that out when you're in the mask shop, or worse, on the processing floor. So our interface basically limits you to only pick the options that make sense for that set of choices. So the next question is, let's see here. We've got quite a few questions. So this is an interesting one. Is there a mechanism to get advice? It looks like you have to be an SoC design expert, including yield calculations, in order to use a system. Can you elaborate on that aspect of it?
Well, that's a good question. Let me go back to the UI. So there are some aspects that we've built into this tool to guide and give some advice. One of them, which is there you can see, is we're showing what do these implants mean. Now Bob, as an experienced manufacturing guy, knew that he wanted the high VT and a low VT to keep power under control and to keep performance up. We're not getting down to that level of detail, but we are explaining what they are to some extent. Embedded in the and as Mike said, by narrowing the choices for the user, we're making the problem a little simpler for you to understand. But through the UI, at this point we're giving, we call it guidance and limited advice. There's certainly a lot of opportunities for us in future generations of this tool to provide more guidance and more advice as to what you should be looking at and what's driving the situation. However, each quote has a contact embedded in it for a salesperson, and in that context, you're able to contact the salesperson and get help to your questions that you might have. You want to add anything to that, Mike?
No, I think that's probably good. By the way, you hearing me okay?
Yes.
Yes.
Okay. Yeah, my computer said you have a USB device that just stopped working, so that was kind of scary, but it's obviously not my headset. Okay, yeah, I think, that's actually a very good question. That's an ongoing focus for the company to improve the user interface and improve the feedback, the tooltips that you saw as you hover over things. And there's another related question in terms of help. We will be adding more and more documentation and more tooltips to this interface. In fact, we have a massive amount of that in review right now that will be updating the interface. So there'll be a lot more guidance here going forward. So that's an ongoing focus for the tool to make it easier to use and more intuitive. Question, is this tool intended as an internal tool? So thank you, that's a great question, and the answer is a resounding no. The background on this tool is eSilicon as a company has a relentless focus on automating pretty much everything we do, all the way from design through manufacturing, through logistics tracking. Those of you who know the company know that we have something called eSilicon Access, which is essentially an online portal that tracks all of the chips we're building for every customer worldwide. So if you're a customer of eSilicon, you have an interface that you can run on your cell phone, on your tablet, or on your desktop that will show you where all your orders are in the world at any given point in time in the process and when they'll be delivered. So we have a large amount of focus on automation. So what you're seeing here is a tool that we have used internally for years to generate quotes for our customers. So When you say this is a new capability, yeah, it's new to the end user, to you, but it is not new to us. We've been using this technology for many years. So the answer is a resounding no. This is available to everyone. So I'll just mention this now. If you want to get an account and generate your own quotes and do exactly what Jeff did, you can do that. Basically, go to our website, our public website, eSilicon.com. On the very top, there's a menu right at the top, and you'll see GDS2 quotes. Click that, and you will get a landing page that will describe the GDS2 quote interface. And at the very bottom of that page is a link to request an account. Simply fill out a few fields, and you will get an account very quickly. I should mention that in an earlier version of this tool, we were requiring an NDA to be executed between ourselves and the end company or the user before we generate the credentials, and that was a PDF kind of paper exercise. I'm happy to report that we've streamlined that process. That's all now done online through click-through agreements, and it's completely automated. So very quick, very easy. I encourage everyone to get an account and try this out. It's available to everyone. So that's a little bit background on that one. Another interesting question, and I think you might want to bring up the quote here. The question is, why is the date SP15_Rev5_2011-715? And I think that's a header in the, or a footer in the, yeah, there you go. Where is that? Oop, go down a little bit further.
This right here.
Yeah, so yeah, that I think the explanation there is that's the version of the contract that we're using. We have standard contracts that are then filled in dynamically by this tool. So that's what that date is. The date that's actually of interest is on the top of your screen there, which is the date of this quote and the validity time. So that's the background on that.
That's right. Yeah, this here is just an internal document control number.
The next one is a very good question. To do the modifications of the quote, can't you just open the last version instead of refilling? And we agree with you completely on that. That's an enhancement that's coming very soon, the ability to take an existing quote, then reload that and just tweak a few things. So that is not available yet, but will be available very soon. There's a lot of usability enhancements like that that are in the pipeline and coming soon. So very good point. Let's see, what else do we have here? This is a good one. Is the automated yield estimate based on die size and process options, or only on die size? And then another question, well, all right, let's do that one first, and then we'll get to the next one. Go ahead.
Yeah, the great question on the yield. It's based on a die size. It's based on the process options. It's based on the number of metals. It's based on eSilicon's proprietary estimations about what's going on with the foundry and that particular process technology node. So it's based not only on the inputs that you've provided, on taking all of them into account, not just the die size, but holistically the entire solution, and combining it with the eSilicon's manufacturing know-how.
Great. Okay. Then related question, is mask yield taken into account for gross die per wafer?
Oh yeah, I'm not sure what mask yield means in this context, but gross die per wafer is calculated based on the die size, the aspect ratio of that die, and the wafer diameter. And there's the user who asked the question probably knows there's many ways to calculate gross die per wafer, and we have a lot of experience in trading those different formulas off and coming up with what we believe is going to be within 1.5 to 2%, if not smaller range, on what the actual gross die per wafer will end up being.
Yeah, I think we're kind of talking the same thing. Some more, just a postscript to that is what the person said is it means how good do you fill the mask with die, and changing aspect ratio sometimes gets you more die per mask.
Yeah, so they know what they're talking about. That's what we're shooting for as well.
That's
because
like
it's
mass
automated
utilization. Yeah.
Yeah, and when we're in an automated situation like we are now, we can do that right away. Oh, and actually, maybe they were speaking about mass field utilization, so I'll just highlight that in the process technology nodes where mass field utilization is an issue, because it will drive a wafer cost, we will report to the user for their die size what the mass field utilization is in the UI. If it's okay with you, Mike, I can just quickly show what I'm speaking about there.
Okay. Yeah, we're running to the end of our time limit. I want to try and keep this to 45 minutes, and we're getting to the end of the questions as well.
Okay, this will just take 1 second. So I am in 28 nanometers, which is a process technology node that shares the impact of mass field utilization. If I go here and I just put in something like 7 by 5, and we'll see that the mass field utilization for that die size and aspect ratio is about 73%. And enhanced versions of this tool will not only provide you the mass field utilization percentage, will provide you what the optimum die size aspect ratio is to maximize that MFU.
Yeah, and that's a little bit of the guidance that we were talking about.
Yes. Yeah, great question.
Okay. So we're down to just a couple more questions. What if you want to use a specialty process that's available? Can you take that into consideration?
Yeah, today we're offering primarily the bulk CMOS processes. We are going to be offering the BiCMOS SiGe processes and some of the other embedded flash processes in future versions of the tool that'll be available in late summer, early fall. So yeah, we're going to just keep expanding this so that the universe of process technologies and what's available in the automated quoting tool is increased.
Okay. All right, so we have one final question. I think this is a good one to end the session on. Hey, your quote's only valid for 2 weeks. What if our project takes longer than that?
Have you ever had a project take longer than 2 weeks, Bob? Yeah, so that's a good one. The quote is valid for 2 weeks in terms of the execution of how long it's valid to execute for. And of course, if the project is expected to go much longer, and once we've signed and agreed on the quote, then the quote is valid for the length of the project.